Okay, so here is a question that one might ask. One might ask, is it the case that for an arbitrary subset of points on the line, an arbitrary subset of points in here, there is a well-defined fact of the matter about the probability that you will pick a point in that set? So we've looked at some special cases, and we know that in that case the answer is yes. So if you just pick a segment in here with a certain length, then the answer is yes, and the probability is equal to that length. There are other cases which are weird, but I think ultimately fine. So suppose that you just pick one point, say R, and you ask, what's the probability that our method will yield exactly R? Well, that will be equal to the probability that your infinite sequence of coin tosses will be one particular way, or in the special case in which you have two notations for a single number, one of two ways. And that is an event of probability 0. So the probability that you'll pick any particular number is 0, but that is not to be confused with the claim that it's impossible to pick that number. So probability 0 just means that it's so unlikely that any positive real number is too big to measure the likelihood that it's going to be that. So we have a situation in which for any point, the probability that it'll be that point is 0, but of course it's guaranteed to happen that some point will be picked. So, you know, it sounds weird at first, but I think that is like a perfectly respectable way of modeling the situation. Unfortunately, it turns out that there are some subsets of this line for which it's impossible to assign a probability. And what I'm going to do is I'm going to give you an example of one such set. So those sets are called non-measurable. And what that means is that it's impossible to assign them a measure satisfying certain constraints. And you can think of a measure as a way of talking about the proportion of points that are in the given set. So if someone asks, what's the measure of L? You can read that as asking, what's the proportion of points on the line that is also in L? So the existence of non-measurable sets can be thought of as the observation that sometimes when you pick a subset of the line segment, there is no fact of the matter about what proportion of points are in your set.